Hey, beautiful people! Welcome to another edition of Math for Grown-ups. Today I'm going to talk about prime factorization. I'd like to apologize about the last video where I was not using my microphone. I mean, I had it on. I just wasn't using it for the recording. Ha! Anyway, factoring. Definition. To factor a number, you write it as the product, that is multiplication, of two numbers, um, and neither one and neither one can be one. That's sort of an interesting rule, right? One is the multiplicative identity. It is a very special number. It is going to be it's going to step aside for prime factorization. No way. Okay, so start with the next number. 2 is can't be factored. There's no way I can multiply it by two numbers, neither one of which is 1. We're going to stick with whole numbers and positive numbers. Can't be factored. So it is what we call a prime number. It is the only even prime number. Every other thing can be divided by 2. So there you go. Very special number. 3 is also prime. Yay, it's the first odd prime. Not so exciting. 4 equals 2 times 2, though. Come on. I'm going to copy this. 2 times 2 is, so there you go. 4 is not a prime number, is called composite. 5 is prime. 6 equals 2, bang, times 3. 7 is prime. 8 is 2 times 2 times 2. Now, okay, now what am I saying? To factor 8, there's ways to factor 8. It could be 2 times 4. It could be, or 2 times 2 times 2. Well, okay. 9 is 3 times 3. A lot of times we'll use exponents. We'll just say like 3 squared. Just to save time. 10 is 2 times 5. Anyway, this is not terribly exciting. This is called factoring a number. But it is the cornerstone of mathematics. We have the fundamental theorem of arithmetic. The most important theorem in all of arithmetic is that every number n which is greater than or equal to 2, every number greater than 1 is either prime or can be factored into a product, the multiplication of prime numbers. And the proof of this is pretty easy. You just go through this process like above, keep going, and eventually you come up to either you can do it for all numbers or you're going to run into a problem. If you run into a problem, you say, well, if it can't be factored at all, then it is a prime number. Bang. And if it can be factored, it's two numbers that are smaller than it, which we've already gone through. If this is the first time we had a problem, the pieces that it's made of don't have problems. Therefore, this never has a problem. The prime factorization of number is like its fingerprint. 10 is 2 times 5. It's almost like the chemical composition of something, where water, we all know, is H2O, 2 hydrogens and 1 oxygen. That's what makes up water. Now, it's in a particular shape, but they generally make that shape themselves. A 10 is a 2 and a 5. We use base 10 as our number system, so these are the nicest two numbers there is. You want to multiply things by 2, you want to divide things by 2, you want to multiply, divide by 5. Those are pretty easy to do. They never go on and on forever because our number system is based off of these. 3s and 7s, those are way crazier. There's some tricks. There's some tricks for knowing how to factor something. The trick for 2, I'll use it here. The trick for recognizing when a number is divisible, that means able to be divided evenly, by 2, and that is it ends in a 0, 2, 4, 6, or 8. We only need to look at the last digit. When a number is divisible by 5, it ends in 0 or 5. And both of these have the same trick, and that is that if you have some number like 5,297 or something like that, this is 5 times 1,000 plus 2 times 100 plus 9 times 10 plus 7. And all of these parts, these are all even. These are all multiples of 2. Multiples of 2. If you had $5,000, you could always divide that evenly. Any number of thousands of dollars can be divided evenly because half of 1,000 is 50. Half of 100 is 500. Half of 100 is 50. Half of 10 is 5. And also of 5. So all the part of a number other than the last digit is automatically divisible by 10, automatically divisible by both 2 and 5. So it's just the last digit. This number is not a multiple of 5 and not a multiple of 2 because the last digit is wrong. And, versus, something like 39702, okay, that last digit is even, so it's a multiple of 2, but it's not a multiple of 5 because it would have to end in 0 or 5. So, and then the last trick, the trick for threes is weird. That 2, 7, 8, 4, 3, 6 or something like that. What it wants to do is you think about 2 plus 7 plus 8 plus 4 plus 3 plus 6. And the question is this divisible by 5? Divisible by 3? And, well, the 3 and the 6 are automatically divisible by 3. But this is what? 9 plus 12 plus 9. Well, all three of these are divisible by 3. For sure, 18. This is 30. And, see, this is thinking about it. And if it thinks about a number that's, because 30 is divisible by 3, this number is automatically divisible by 3. If we changed one of the digits so that this would be a 7, and so now, so now if this is a 7 now, so then this would be 11, and then this becomes 29. Now suddenly this number is not divisible by 3. Kind of a nice trick. In general, it's really hard to factor numbers. To factor numbers can be quite hard. And in fact, this is how cryptography is generally done when you buy things online and such like that. They take two big prime numbers and multiply it together, and then they say, okay, this is my secret number. Anybody who knows the two numbers that make it up can undo the information and reveal secrets, but it's so hard to factor a number with 200, 300 digits to break it down. Which two prime numbers? There's so many prime numbers it could be. But if someone says factor 126, you think, okay, that last digit, it's divisible by 2, but not by 5. So 126 can be divided by 2, and it goes 63. I'm doing sort of a shortened version. And then 63, not divisible by 2, but 6 plus 3 is 9. It's divisible by 3. So you divide by 3, and you get 21. And 21, 2 plus 1 is 3. It's still divisible by 3. In fact, if a number is divisible, if you add up the digits and it's divisible by 9, the whole thing is divisible by 9. 3 times 7. And now these are all prime numbers. And so that's your prime factorization. 2 times 3 times 3 times 7. Of course, you can put them in any order you want because multiplication is commutative. Maybe you call it 2 times 3 squared times 7. That would be sort of put them in order and use exponents, but that is not necessary. Some people do like this tree diagram they're taught where you go like this is 6 times 21, and then this is 2 times 3, and this is 3 times 7 or something like that. But a lot of times you need to do some sort of long division to figure out. Is it immediately obvious that this is 6 times 21? Maybe not. Anyway, that's enough for today. You guys have a beautiful day.